Hello everyone, welcome back to this course. So this chapter was about determinants. So we talked about the cofactor of an entry, and if you remember, we had Cij equals minus 1 I plus j times the minor corresponding to ij, which is mij. And so first, let's start with a remark. If you have a n by n matrix A for a given entry aij, the sign of minus 1 I plus j, which is used in the definition of the cofactor, this can be obtained from the following matrix. So in this matrix, if you let I equals 1 in negative I plus j right here, and if you let j equals 1, then I plus j becomes 2, so minus 1 squared becomes plus 1. So that's why we have a positive. And consecutively, when you walk in a row or column, then the sign gets changed. So this is a nice way quickly to figure out this minus 1 I plus j without writing or computing. So that's why we have Cij equals mij when I plus j is even, and minus mij when I plus j is odd. Definition 6.1.4, cofactor expansion. Let A be n by n matrix, then the cofactor expansion along the ith row is the following. So first, what we do is we look at the entries in the ith row. So this is the ith row. We'll look at the entries. The first entry, we compute this entry and we compute the corresponding cofactor for this entry, and then for all entries in this row, including ain, we compute the corresponding cofactor, and then we multiply the entries to its corresponding cofactor, and then we add them up. So what we have in sigma notation, we have sum a I, put a variable t, ci variable t gets changed from 1 to n. So we can talk about the cofactor expansion along the first row, the cofactor expansion along the second row, keep going all the way to the cofactor expansion along the nth row. So we have n of them for rows. And then we have a similar definition for the cofactor expansion along the jth column. So if you look at the jth column right here, then we look at the first entry in this column. We compute its corresponding cofactor, which is C1j, and then we multiply the entry to its cofactor, and we keep going for all entries in this column. And then we end up with this definition. And if I write in sigma notation, I get A, Rj, C, Rj, R starts from 1 to n. To understand better, let's do an example. So example 6.1.2. So a 2 by 2 matrix is given, 1 with entries 1, 4, minus 1, 2. And the question says, evaluate the cofactor expansion along each row and each column. So let's compute the cofactor expansion along the first row. So we have to just look at the first row. And then we write the let me write the details because it's the first one. A11, C11, A12, C12. So what is A11? So 1. What about C11? C11, if you remember, it was minus 1, 1 plus 1. And then the minor. How do you compute the minor? You just copy the matrix. And then you delete the first row and the first column. And then plus, let's compute, let's put A12, which is 4. And then minus 1, 1 plus 2. Of course, we just had a fast way to determine this sign. I will use that in the when I compute the second row, the cofactor expansion of the second row. Let's copy the matrix. Let's remove the first row and the second column. What do we end up with? So 1 times minus 1 squared is just 1 times 2 is 2 plus 4 times minus 1 times minus 1. So the answer is 6. Let's calculate along the second row. So along the second row, if you look at the second row, you have minus 1 and 2 in the entries. So minus 1, C, 2, 1, and we have 2, C, 2, 2. So we end up with minus 1 and then C2, 1. Okay, first, let's quickly find the sign of that negative 1, I plus j. So here is always positive, the next one negative, the one below that, this positive is negative, and this one positive. So since we're talking about the second row, we have negative and positive. So we have negative 1, and the determinant, just copy the matrix. 1, 4, minus 1, 2, plus twice. And then we have positive 1. Then determinant 1, 4, minus 2, 2. Let's remove the second row and first column here. And here's second row, second column. What is the answer? The answer is just 4 plus 2, so 6. Now, I'm sorry. Let me calculate the cofactor expansion along the first column, which is, now I write less. Let's look at the entries in the first column. In the first column, we have 1 minus 1. So 1 times, about positive, negative, you have plus and minus. So 1 times plus 1 times 1, 4, minus 1, 2. And then you have minus 1 times minus 1 times 1, 4, minus 1, 2. And then let's remove. We're talking about first column. So you have first row, first column. Then you have second row, but it's still first column. Why? Because this is C. So it corresponds to C11 and C21. So 1, 1, and 2, 1. And then the answer is just 2 minus minus plus 4. So 6. And let's calculate the cofactor expansion along the second column. For the second column, the entries are 4 and 2. The sign is minus and plus. So 4 minus determinant 2 plus determinant. So the determinant here is 1, 4, minus 1, 2. Here 1, 4, minus 1, 2. Now we have to figure out what to remove. For the first one, we're talking about this entry. So it's first row, second column. First row, second column. And for the second matrix, we're talking about this entry. So second row, second column. So second row, second column. And the result is just 4 times 1 plus 2. So again, 6. Observe that all of them gave us 6. That is important in theorem, in our computations later. Indeed, we will see it's a nice result. Okay, it's enough for today. We'll continue in the next video.